Hello. Today we're going to discuss Newton's law of universal gravitation. This is the fourth of Newton's laws that we're going to discuss, all four of them being fundamental to the beginning study of physics. And you're probably thinking, well, Newton was a genius. We've seen his name a lot. You're correct. This is the last of Newton's laws that we're going to discuss, and let's talk about it. This is one you've probably at least heard the folk story about. Newton was sitting in an apple orchard, and an apple fell. According to some stories, it fell on him. And he saw this or felt this and realized, oh, well, gravity, okay, discovered gravity. That story is probably not true, and it certainly is not true that he discovered gravity. People knew about gravity. They observed things falling, felt the pull of gravity. In fact, 100 years earlier, Galileo had done experiments on the acceleration due to gravity and found out that the acceleration of gravity doesn't depend on mass. Newton did not discover gravity, but he discovered something about gravity. There had been a problem in astronomy for a long time of why do things go the way that they go. And you've probably heard some names like Galileo, Copernicus, Kepler, discovering certain things about the motion of planets. Newton saw this apple fall, or was thinking about things in general falling, and he thought, okay, well, I feel the pull of gravity, but I'm attached to the Earth. It's kind of weird that gravity can reach up to this tree and pull an apple out of the tree down to the Earth. Well, if gravity can reach up to the apple in the tree, can it reach to the birds flying above the tree? They're really not attached to the Earth. Well, yeah, I mean, they have to flap their wings to stay up. If they didn't flap their wings, they wouldn't stay up. So gravity must be pulling them down too. And if it reaches to the birds, does it reach to the clouds? Does it pull clouds down? And if it reaches to the clouds, then does it reach farther than that? And he realized Newton understood the concepts of inertia ball, right? He understood that if you've got some object and it travels in a circle, well, then there must be a force on this object constantly pulling it toward the center of the circle, no matter where it is. Forces cause acceleration, and one of those ways of accelerating is to change direction. And an object going in a circle is always changing direction. So the force on this object, as we discovered, Newton understood, must always be toward the center of the circle. Well, the moon moves in a circle around the Earth, so it must have a force always pointed toward the Earth in its travel around the Earth. And Newton realized that gravity force extends to the farthest reaches of the universe. Newton realized that gravity force is what pulls the moon toward the center of the Earth, no matter where it is, and that gravity was the force that was causing planetary motion. He realized that gravity force goes forever. It acts on all objects. He was actually able to put this together in a law that is a physical equation to tell us about how gravity force works. And he discovered that things that have more mass feel more gravity force. So gravity force must therefore depend on the mass of the object. It has something to do with the mass of the object. It probably has something to do with some other things too, so I'm leaving some room here. He realized that, for example, I have more mass than my calculator. So I get pulled down with more force than my calculator does. But why don't I get pulled toward other things that have mass? If it's things that have mass that are causing gravity force, then why don't I get pulled toward the desks in this room or toward any other object with as much force as I get pulled toward the Earth? And Newton realized that it's the mass of the object causing the gravity force. That has something to do with it too. So I'll label that with a big M. There are two masses involved. He also realized that if I go farther away from this object, the force becomes weaker. So if I go farther away and the force gets weaker, then it must be in the denominator. And finally, he actually did some experiments and realized that it depends on the denominator, or on the distance squared between the two objects. So this is Newton's law of universal gravitation, and he plugged this into his calculator, or equivalent, as it were, and he actually found the slope of it. You graph the two masses times each other divided by the distance squared versus gravity force, and you get a slope. This slope is labeled by what we call big G, or the universal gravitation constant. Other people have found the value of this to be equal to 6.67 times 10 to the negative 11th Newton times meters squared over kilograms squared. And so that's all there is to it. If you plug in the two masses of the two objects into this equation and the distance that separates them, and multiply all that by the universal gravitation constant, you can calculate the force gravity. So we'll try that in another video. But that's it for today.